Welcome to this exercise on calculating derivatives for function with one variable. Here we have two functions for which we should calculate the first and second derivatives. So let's start with the first one, x to the power of 3 plus ln of x squared. Well, if we take this function, before we start, we can actually simplify this a little bit by applying one of the rules for working with the logarithm. And there's a rule, logarithm of a to the power of b is the same as b times logarithm of a. So in other words, I can take the exponent and pull it in front of the logarithm. This is actually a good rule to apply here because it will make calculating derivatives much easier. Because this is easier than this because we do not need our chain rule, which we would have needed if we worked with this way. So here we can just calculate the first derivative by getting the derivative of x to the power of 3, pulling the 3 in front, so 3x, this minus 1 to the power of 2, plus 2 times, can pull the 2 down here. Then I look up the derivative for the ln, which is 1 divided by x. So this was relatively fast and easy. The second one is equally easy because here I'm going to pull the 3 down, keep it, then get with the derivative of x squared, which is just 2x. So 3 times 2x gives 6x. Here I keep the 2 and have to take the derivative of 1 by x. Well, I could reformulate this as well by thinking about it as x to the power of minus 1, because then it makes it a bit easier. Then I can pull the minus 1 in front, and x to the power of minus 1, I have to subtract 1 from the exponent, so I get minus x to the power of minus 2. And well, x to the power of minus 2 is nothing else than 1 divided by x squared. So that's how I get to this part here. And well, that's then already everything for this first function. And you see we could simplify the calculation a lot by applying this logarithm rule. The second function b, there we actually have to do a little bit more, because again, we have one function applied to another, but here we cannot use any ways to simplify this. So here we actually have to use this chain rule, which is derivative of the inner function times derivative of the outer function, where we still have the original inner function inserted. Well, let's first define inner function and outer function. Our inner function is 1 plus x to the power of 3. Here we can calculate the first derivative. Well, 1 is a constant, so derivative is 0. Then we need the first derivative of x to the power of 3, which is 3 times x squared, as we know from a. Then we also need the outer function, which here is sinus, because I'm applying the sinus on this inner function. So here we take as outer function sinus of z, and the derivative of sinus is cosinus. Then I can build with this my derivative by taking derivative of inner function 3x squared times derivative of outer function cosinus of the original inner function 1 plus x to the power of 3. Well, so much for the first derivative. The second derivative gets to be even a bit more complicated, because if we look closely, we see here I'm multiplying this term with the cosinus, and in the cosinus I have something else. So I need to use the product rule, and in the context of the product rule I have to use the chain rule again. So we're going to do this here. As I said, I need product and chain rule. So here are the rules for this. If I start with the product rule, the left side of the product is 3x squared. Here I know from part A the derivative is 6x. H, the other side, is cosinus of 1 plus x to the power of 3. And here I would actually have a problem calculating the derivative directly because I have to use the chain rule. So from here I'm skipping over. The inner function again is 1 plus x to the power of 3. And its derivative, similar to the first derivative, is 3 times x squared. The outer function, where I have this inserted, is cosinus of z. And the derivative of cosinus is minus sinus of z. Okay, so much for this part. Now I'm going to build this derivative of this function. So I take derivative of inner function, 3x squared, putting this here, and then times outer function derived minus sinus of z, but instead of z I'm going to insert the original inner function 1 plus x to the power of 3, giving me this result here. Then I have all the parts I need to use the product rule. I'm going to multiply them crosswise. So those two plus those two multiplied, giving me this result. So this times this is this first part. Here I have a negative sign. So instead of plus, I write minus, and then this times this, giving me this result, which I can summarize together and get a slightly more comprised answer for the second derivative. And well, this then is the second part of this exercise, bringing me to the end of this exercise. So I say goodbye and see you next time.